Types of functions. We have constant functions. Constant functions are always the same, no matter what you put in. That ends up being a horizontal line. It never changes, going up, going down, hence the name constant. We have direct variation, which, once again, remember, a direct variation is a special linear line that goes, wow, that's redundant, linear line, a special line that goes through the origin. Then our identity is a extra special line or a special direct variation, which also has a slope of 1. Our greatest integer or step function, once again, takes any fraction, rounds it down to the nearest integer. Absolute value is always the shape of a V. Quadratic is a parabola shape, kind of a U, either going up or a U going down. We also have a square root, which is really just half of a parabola opening sideways. Then we have inverse variation. Inverse variation is really a special rational function in which our vertical asymptote and horizontal asymptote are the x-axis and the y-axis. If it looks like it's a rational function, but the x-axis and y-axis are asymptotes, it's a special one and it's considered an inverse. Now remember, with rational functions, you have vertical asymptotes and you have holes. So if it's a hole, it's rational. If you have a vertical asymptote, it's rational. But if that vertical asymptote and horizontal asymptote are on your axes, then it's an inverse. So as we look over here on the left, at the bottom, this one is which type of those graphs from above? Well, it's half of a parabola going sideways, so it's a square root function. This one here has a hole, so it's rational. As we read through this, we have a toy rocket. It's being shot off from the ground. The height above the ground after so many seconds is given to you by this function. Which graph would this be? Well, we have a t squared, so we know it's not a line. A t squared and another t is quadratic, so that's going to be our parabola, which is B. Now, to be able to graph any of these functions, you can always go ahead and make yourself a t-chart. If you make a t-chart for here, remember, you can make an xy chart, but you set what's on the inside of the absolute value to be 0. And in this case, we just get x being 0, and then you choose points on each side of that on your t-chart. It's absolute value, so you're going to get that V shape when you plot your points. Remember, in graphing radical functions, you want to take what's on the inside of your root, which can't be negative, set it to be greater than or equal to 0 because it can't be negative, solve it, and you get x to be greater than or equal to 0. Then you make a t-chart with x value starting at 0 and going up from that. When you plot those points, you get this shape. Remember, going back to graphing rational functions, which we did back in section 5, you can go ahead and factor the top and the bottom because you want to look for holes. In this case, we have a common factor top and bottom, so we're going to have a hole at x equaling 3. And when you look at what's left, you just have x minus 3, which is a line, slope of 1, y-intercept negative 3. And we're going to have a hole at, this is supposed to be a negative 3 here, so we'll put that in there. X equals negative 3 is where your hole is, and that's what we have on our graph. Remember, to find the y-coordinate of that hole, you take negative 3, plug it into the simplified, you get negative 3 minus 3 is negative 6. So it's negative 3 comma negative 6, as you can see on your graph.